defending a support price, fighting low liquidity price manipulation, or temporarily forcing a certain input price for your algorithm. Those are common situations, and the market maker needs tools to handle them properly. On OctoBot Market Making, a market making strategy always uses a reference price, which tells the bot how the fair market price should be computed. This fair price is then used to build and update the market making order book. So its value is a critical component of the market making strategy. We designed this reference price configuration to be extremely flexible while remaining simple to use. An OctoBot market making reference price can be computed either from the local exchange or a different exchange or a mix of both. It can also be forced as a static value, and it can also be dynamic, maybe by using the historical price of the pair or any other custom logic to interact with the market in a way that makes sense for your token. First thing to do when you execute a market making strategy is to get the fair price of your market. Only then you can start building your order book. The simplest way to do this is to use the market price directly on the exchange you are doing market making for. This is usually the case when your token only trades on a single exchange, for example, after a first exchange listing. Now, in most cases, the market exists on other exchanges as well. Then, you want to avoid creating arbitrage opportunities and usually want to use the most liquid exchange as the primary fair price source. OctoBot Market Making allows you to do just that. You can even select many exchanges as price sources and assign them weights, in case some are more important in the final price calculation. But what to do if you have no way of knowing the price of your market? But you know that for now it should be, for example, at least 1.5 USDT. This is often the case during a token launch, when you want to initialize your market around your public sale price and then let the market decide how the price should evolve. Another interesting use case for static reference price is for HollaEx-Powered exchange operators. In case you don't know the system, HollaEx is a great open source toolkit to easily create crypto exchanges. As OctoBot Market Making is built on OctoBot, which is fully compatible with all HollaEx-powered exchanges, it's natively compatible with all HollaEx-based exchanges. On those exchanges, there is often a need for local currency listing. For example, in order to trade a country's local currency for USDT. As the value of this local currency in USDT is usually overall stable and might not exist anywhere else, using a static reference price is a great option here. And of course, as any OctoBot market making configuration, a static reference price can be updated at any time, so it's actually static until you decide to change it. And this leads us to the most advanced price mechanism of OctoBot market making, dynamic formulas, which is a mix of exchange price, static values, and transformations. What if your market is often manipulated, and as a result, the latest price can't always be trusted? For example, what if a whale buys the whole order book and then sets a new price at 10x the real price? Then you don't want your market making strategy to start creating buy orders using this manipulated price. Instead, you want to use the price before manipulation and not get fooled by the whale. With OctoBot Market Making, many formula keywords are available to do this. For our whale example, we could use a moving average of the last 10 candles of our market to compute our real price. Or we could even use volume-weighted moving averages, and therefore being immune to such manipulation, which are actually quite common in very low liquidity markets. Dynamic formulas are also great to interact with the market. As a crypto token project, there are times you want to show strength in your price. For example, upon listing, or to execute buyback campaigns. Each token also has important price levels, such as, for example, its public and private sale prices, which could be defended as support zones. All of those can be translated into dynamic formulas. For example, support zone can be explicitly listed to be defended by the market making strategy. Another use case is when a project expects a price increase. Then, shifting the order book slightly upwards gives more room for upward price discovery. This is just the tip of the iceberg. There are tons of use cases possible with the formula system, and we are adding new keywords on a regular basis, so it's only getting better. If you want to know more about dynamic formulas and view the keywords list, check out our guide. I added a link to it in the description of this video. At OctoBot Market Making, our goal is to provide the best tools to let crypto projects automate their market making strategies by themselves. Whether they are crypto token projects or exchange operators, may be using the HollaEx open source exchange framework. If you're interested, just book a call on our calendar and we will show you the platform and give you a few days of free trial to test everything by yourself. In this video, we mentioned price manipulation and how to fight it. On OctoBot Market Making, we also created a system dedicated to protect your funds from such events. It's called Stop Conditions, and we also made a video about it. Link is in the description below. Thank you for watching and see you next time.